Hello everyone. Warmest regards from one of our Nuclear Technologies Information Center. My name is Tatiana Yanichkina. I am Director General of Energy of the Future, a non-for-profit organization which runs information centers and public education programs on nuclear in the countries implementing nuclear technologies. So, welcome to the world of splitting atoms. Nuclear energy brings a long list of tangible benefits to newcomer countries. Clean and reliable energy, access to electricity with predictable and affordable prices for decades to come, boosts economic growth, high-tech sectors, entrepreneurship, education and science, and even creates new industries. But at the same time, nuclear projects are associated with stereotypes and fear about radiation. Anti-nuclear advocacy groups are likely to stir opposition among stakeholders to make the project controversial. The lack of public acceptance could in turn delay or even cancel new build projects. We need to earn and ensure public trust by keeping people informed and engaged in an open and transparent manner. That's actually the main purpose of the information centers. The main challenge is how to communicate complex scientific and engineering ideas to the general public in a way it is easily digestible. I'm now going to show you some of our installations, demonstrating how we have dealt with this very problem. By both entertaining and educating people, we hope that our edutainment installations allow the public to retain and process this complex information easily. So let me show you around. We need energy as much as we need food, water, clothing, and place to live. Electricity has opened up enormous opportunities for mankind. We have learned how to generate power from various energy sources, from wind, water, sun, fossil fuels, and atoms. The human body can also generate electricity. All of us here can do this right now. If my cameraman will assist me, we together can try to power up the city behind me. Okay, let's see what we can do here. Not much so far. Speed up. City needs power. Don't stop, keep moving. Just a few buildings left. Yeah. In the past minute, we generated enough energy for a mobile phone to work for about a minute. That's about 0.001 kilowatt hour. Imagine how much you would need to paddle to keep the lights on, boil a kettle, or binge watch your favorite series. Even if we were to paddle all day long, 24 hours, we would generate less than 8% of what an average urban household uses in day-to-day life. That's way too much for a workout. Within the same time period, just 1 minute, 1 gigawatt nuclear reactor generates 20,000 kilowatt hour of electricity. Enough to charge 250 million mobile phones or up to 1 million homes with kettles, TVs, washing machines, and even air conditioners. Impressive. But atoms aren't just about energy. They can also save lives. Nuclear medicine helps to prevent, diagnose, and treat many diseases and life-threatening conditions. CT, MRI scans, and X-rays are used to spot something going wrong in the body before it's too late. If detected at early stages, many deadly diseases and conditions previously considered fatal, in fact, can be treated. Across the globe, nuclear medicine saves millions of lives every year. The most famous and popular nuclear imaging technologies is so-called PET, positron emission tomography. With the help of such devices, doctors get images that allow them to observe the chemical processes in the body and functioning of organs at the molecular level, thus detecting more subtle changes in the patient's health earlier than using other diagnostic methods. Various carefully selected radioisotopes are used for specific organs and tissues. For example, xenon-133, the isomer technetium-99, and iodine-123 are used to study brain function. And thallium-201 and rubidium-82 are used for health research. On average, the longest half-life of the above isotopes is 73 hours. For all other medical isotopes, radioactivity halves every 3 hours until safety dissipating. In many countries, people have to travel miles for an MRI scan or cancer treatment. Going nuclear means bringing access to modern healthcare for those who previously even haven't dreamed of affording it. Food is something we cannot dispense with. Nuclear is of great help there too. According to the UN, approximately 1/3 of all food produced in the world every year is wasted. A mind-blowing, outrageously high figure, especially when at the same time about 1 billion people on the planet are starving. Why does so much food get wasted? Well, in agriculture, crops and fruits could be damaged by insect pests or bacterial disease. But an unacceptably high number of products that reaches the supermarket and shops ends up dumped simply because it is not used by the end of its shelf life. So what's the answer? Well, there are 4 ways in which nuclear can help. Unlike with chemical preservatives, which we end up digesting, irradiated food does not become radioactive. Exploding food to ionizing radiation is enough to kill harmful bacteria, increase shelf life, and keep insect pests at bay. But no substance comes into contact or changes the matter to make it radioactive. It is a completely safe process. We can breed new varieties or even classes of plants, cultivating traits we need, which is called radiation selection. With the help of this technology, we can boost plant yield and enhance their resilience to cold and harmful bacteria. Increase germination and yield. Seeds irradiated with small doses of radiation germinate faster than those not irradiated, and the plants turned out to be healthier and more fertile. Protection against insects. Insects are sterilized by radiation and released into nature. Wild insects interbreed with sterile ones, so cannot produce offspring, reducing their population. And preservation. The irradiated crop of fruit could be stored longer than usual because with the help of radiation, harmful microorganisms are destroyed. As they say, it's better to see something once than hear about it 1,000 times. So, in that spirit, are you all ready to watch a film? Follow me. This is the video room of our Information Center for Atomic Technologies. This is where we show educational films about energy and non-energy applications of nuclear technologies. These school children are watching a film called Atom Riddles. The film shows them the inside of an atom, how particles form a structure, and how it is changing to absorb and release energy. It also allows kids to see the inside of a nuclear reactor and a nuclear power plant control room with their own eyes, so that they can see how a nuclear power plant works, its safety system, etc. For them, the atom is no longer a riddle. It is part of life and an endless source of bright, useful thing around us. But now it's time to say perhaps the most important thing. Nuclear is not just desirable, it is absolutely vital. Evidence is mounting that without nuclear energy, which has almost zero emissions, the world as we know it is doomed. Climate change and air pollution are destroying the planet, causing hundreds of thousands of premature deaths every year, mass extinction of species, and negating the benefits of economic growth. About 450 nuclear reactors operating in the world today prevent 2.6 billion tons of CO2 emissions every year. To put it into perspective, all the trees and forests on our planet absorb just 2.5 billion tons of CO2. Scientists argue that unless we build and connect to the grid about 10 to 20 new large reactors worldwide each year in the coming decades, dangerous global warming will become irreversible. Every new nuclear-built project, every new nuclear power plant is a great contribution to our fight against climate change. This atom installation made of light flowers will continue to thrive through nuclear power. Let's make nuclear happen. It depends on us, on everyone.